Okay, now we're taking a look at simplifying square roots. So let's remember what some of these square roots are. So if I took the square root of 9, you may recall that that's just the number 3. The reason it's 3, it's because 3 squared equals 9. Squares and square roots are like inverse operations. Okay, same thing here. We've got square root of 25 would be 5, since 5 squared equals 25. So whenever we're simplifying square roots, or any index root by that matter, it could be a square root, cube root, or fourth root, then we're looking for a factor, generally a prime factor, that has that same exponent within the number. So, for example, if I were to take the square root of, let's do 75. If I were to do the prime factor tree, which basically means divide this by whatever you can and keep going, as long as you don't use the number 1, go as far as you can. So 75, I think of 3/4, right? So 3 times 25. You may recognize 25 as a perfect square, but if you don't, that's okay. And divide that 25, we get 5 and 5. Now everything that's left is prime. It may help for some of you that are visual or kind of get lost in the minutia there to write out all those factors so we don't lose anybody. And notice, of all of those factors, 2 of them are alike. In other words, 5 times 5 gives us a 5 squared. So if it's a square root, you look for a pair, and every pair 1 can come out. So this would give us a 5 on the outside now of the square root, but this 3 does not have a pair, so he has to stay in. So remember, square roots undo squares. So that's why it equals just the 5 on the outside, because the square root undid that 5 squared, but the 3 didn't have a squared, so he can't come out. So he stays in. Let's do another one. Let's do the square root of 27. If we were to break down 27, we would get 3 times 9 and 3 times 3. So we actually have 3 3s here, which is awesome, but it's still a square root. The understood index here is a 2. So you only look for a pair. Well, I have a pair of 3s, which means one of those 3s can come out. But this 3 was not part of a pair, so that 3 has to stay in. Okay, so you may want to write yourself a note. This guy goes out, this guy has to stay in. Same thing here. You have 2 of a kind, so that means one of those can go out. You did not have 2 of a kind, so that guy had to stay in. Let's do the square root of 450. So this one is a little bit more involved, right? I notice there's 450, so I could technically divide by 10. You don't have to. You could divide by 2 or divide by 5. All of the prime factors will break down to the same thing. The 10 is a 2 and a 5. The 45 is a 5 and a 9. And the 9 is a 3 and a 3. So if we broke that down, we have a 2 and a 3 and a 3 and a 5 and a 5. Again, prime factors. And since this is an understood square root, we're looking for a pair. So this guy here is 3 squared. This guy here is 5 squared. So that means a 3 can come out and a 5 can come out, but we still have this 2. It's not part of a pair. So he has to stay in, which means we would have a 15 square root of 2. The same thing works for variables, but one of the things to recall with a variable is x times x gives us an x squared. If we were to square x squared times x squared, we would get an x to the 4th. If we were to have x cubed times x cubed, we would get x to the 6th, or we can write it like this, x to the 4th squared would give us x to the 8th. So notice anytime we square a variable, regardless of what its initial exponent was, notice we are, oh, I said 8 and I wrote 6, didn't I? Ding. So notice on all of these, we are getting even exponents. So anytime you have an even exponent, that means you have a perfect square with a variable. You just have to divide it by 2. So for example, if I had the square root of x to the 10th, we could just divide that 10 by 2, and that gives us x to the 5th. We had the square root of x to the 80, power of 80. You still just divide it by 2. X to the 80 divided by 2, that gives us x to the 40th. Now, what if it wasn't even? Suppose we had x to the, I don't know, 27th. You would still divide it by 2 and look to see how many times it goes in even. It goes in there, what, 13 times? But you have a remainder of 1 if you divide 2 into 27. So that means you have 13 x's that come out and 1 x that stays in. That remainder tells you how many x's stays in. That method there works whether it's a square root, a cube root, or a fourth root. Whatever your index is, that's what you divide by. Okay. And we're going to talk about rational exponents later on anyway. Okay, so hope that helps. Talk to you guys soon. Bye.